Hello, world and universe. I'm Jay Sherm, and today's episode of Future Tech, I want to talk about why the James Webb Space Telescope images from NASA are just so amazing and incredible. Let's just talk about the fact that the images that have been released, as the scientists have said, you can hold out a grain of sand in your hand, a grain of sand, okay? And the cluster of galaxies, the S-Max 0723, is this huge cluster of galaxies that is, 13 billion years old, right after the Big Bang. And that grain of sand is equivalent to what the JWST, the telescope, captured in that image. So it's just this little dot in space that it pinpointed, but that dot became thousands or millions or billions of galaxies, because like every single object or image inside the picture is a galaxy or a star. So just look at the photo, look closely. And for those of you who don't quite understand what you're looking at, it is a couple 100 million years after the Big Bang happened. We're seeing the galaxies that were forming right after that. After the Big Bang, there was this cosmic dawn. It was like this dense fog of primordial gas, and light can't reach us from that area because it's called like the cosmic dark ages. After the Big Bang, we're not exactly sure what took place besides chemical reactions between gases, and like the stars started forming and planets started forming and gases and elements started kind of colliding and forming planets and galaxies. So by seeing S-Max 0723, that galaxy photo, or the multiple galaxy photo, we're actually seeing what happens right after the cosmic dark ages. So that's extremely important. The fact that the light had to travel to us over 13 billion years, because, light travels, 186,000 miles per second. It had to travel to us. So the telescope is actually looking back in time. If you think about that, the telescope is seeing light that traveled to us over 13 billion years ago, and we're seeing it now. Same goes for the Karina Nebula, which was an area of star formation. It looks like orange mountains. If you look at that photo, it's one of the most beautiful photos I've ever seen. I'm using it as my desktop wallpaper. And again, it's seeing back in time. It's a nebula, and now we're looking at also the quintet of galaxies that the JWST captured. It's called Stephan's Quintet. That shows 5 galaxies, 2 of them colliding and like maybe merging, right? And we couldn't see these things before. The Hubble Space Telescope is a little over 7 feet, or a little less than 8 feet, 7.8 feet. And the JWST is 21.3 feet. So it has 6 times more light collecting area. And this means that it can capture more imagery, more light, which gives it a much clearer image. Plus, the Hubble is using UV standard light, which is what the visible eye can see. JWST, NASA decided to go with infrared light, which can look through these dense clouds of dust and gas. It can see stars behind these clusters of fog. It can see distant universes because it's capturing infrared light, which is extremely, bright to infrared light. And even the faintest light 13 billion years ago, it can capture that because it can see the infrared. Now, some people were asking me, well, why is that image, why is it warped? Why are the galaxies spread out? Why are they bent? And this is actually something that goes back to Albert Einstein. Albert Einstein predicted the effect of something called gravitational lensing over 100 years ago. And basically, it's space getting warped by a lens that we look through. So imagine looking through a lens and it's like warping it. So let's say you see some galaxies, right? And in the case of the S-Max 0723 image of all the galaxies, there's light from the galaxies behind the cluster. Okay, so the Webb telescope is seeing a distorted version of the galaxies because it's like having a camera lens. The galaxies are providing like a camera lens between the telescope and the galaxies behind them. So think of it like this. In the image, you might see 10,000 galaxies. I'm just putting a number out there. I know it's a billion or whatever. Let's just say 10,000 galaxies are in the foreground of the image. Those galaxies are a lens to the other million galaxies behind them, which warps them. It's actually really freaking cool. Scientists are really excited about the infrared capabilities, as well as the fact that it can study exoplanets. Now, this is where things, at least in my opinion, get very interesting. Before, we were only able to see the gravitational pull of a star, a sun, on a planet, which would help us see the planet going around this star. But now we're able to observe the stars that those exoplanets are orbiting, which means the light that's passing through the star is like acting like a filter through the planet's atmosphere. So we can study that light, we can study it from the filter, and we can actually finally study the composition of the atmosphere on those exoplanets. So just imagine the billions of planets, the trillions of stars. We can finally start to find out what kind of atmosphere these planets have in other galaxies. Are they habitable? Do they have oxygen? Is there water? Which they found one planet or exoplanet had water on it, water vapor. This is huge. By studying the atmosphere and the gas properties and the temperatures of these planets, we will finally be able to find potentially habitable planets. Because although we're going to the moon and Mars, that's already in the works with the Artemis mission, and Elon Musk, SpaceX, is really on his way to Mars, they're not habitable. We have to build these habs, and we have to live on the ships, and we have to terraform the planets, and these are going to take 100 years to do. So in our lifetimes, we're not going to be visiting these planets. Not to mention, we don't have light speed travel yet, which means it's going to take 2 years round trip, including stationing on Mars. So without light speed travel, we're kind of earthbound. But at least with Webb, the telescope, we can look back in time and we can find these habitable planets. So you guys have to really understand how interesting and incredible these images really are. One of the oldest questions humanity has been asking is, where did we come from? What are we? Are we even, living beings? Are we just energy formed from atoms? Look, the Big Bang happened. We don't know where that came from. We don't know what happened before the Big Bang. Was it a couple of aliens throwing a marble game, and one of them exploded and turned into our galaxy? What is the expansion of the universe? It just keeps expanding. The explosion of the Big Bang is, if you really think about it, the universe is basically just an explosion. And it's still exploding. Although from what I understand, it has slowed down. And also 95% of the stars and planets and galaxies that the Big Bang was going to provide us have been created, apparently. We're at the tail end of the creation, which, again, this is all very, interesting to understand, but also kind of hard to understand in a way. Where did we come from? And we're trying to find that out. The closer we can get to the Big Bang, which the Webb telescope is going to get us, the more understanding we will have as to what we are. What is Earth? What's the Milky Way galaxy that we're in? What are the other galaxies? What are black holes? Are we alone in the universe? Are there other habitable planets out there? Are there wormholes? Is there a way to travel through space quicker? I mean, these are all potential questions that we as humans have been wanting to know for centuries or thousands of years. And now we finally have a technological advancement that's going to get us there. And I don't think a lot of people understand that. I really don't. And that's why I wanted to do this episode. Keep in mind, the people at NASA have been working on this project for decades. I don't think anyone understands that either. It was a $10 billion telescope. $10 billion. People have dedicated their entire lives to building this telescope. There have been budgetary delays, technical delays. There were so many issues. And the fact that they were able to finish the telescope, test it on the ground, make sure it would open up properly and calibrate properly, launch into space without any problems, deploy the telescope, slowly unraveling it and opening it up over time because it took time. It's in the Lagrange point between the sun and the Earth. So it's blocking out the sun with the tennis court size sun shields. The fact that they were able to build all of this, get it up in space without any issues, to me is extremely impressive. And now we're reaping the rewards. Now we're seeing the imagery that this telescope promises. And the data that we're receiving from these images, because keep in mind, we mere mortals are just seeing the images with our eyes. But the scientists at NASA and all the other scientific communities or organizations that are privy to the data that the telescope is sending back, because they're getting all sorts of data. They're getting atmospheric conditions. Is there water, chemicals, light? Light can tell a lot of stories because there's a lot of different types of light. I mean, they must be getting a ton of data. I want to know more about that. But in the meantime, at least we get to see the beautiful majesty of the universe as it was just a couple of 100 million years after the Big Bang. So be impressed, be curious, be excited. Keep your eyes peeled for more James Webb Space Telescope images like the one they released of Jupiter and its moons. That's cool because it looks extremely clear, and I love seeing stuff like this, so I can't wait to see more. What are you guys excited to find out about the Webb telescope? Tell me in the comments. What did you like about the images that you did see? I want to talk to you about it, and as always, I will see you in the next episode.